So today we're going to talk about quadratic graph characteristics. Our quadratic equation can be represented in various forms. We have our factored form, where we have our two factors that are multiplied together. We learned about factoring in the last unit. We have our standard form, ax squared plus bx plus c, and it looks exactly like our quadratic formula, what we would use to plug into there. And then we have our transformational or vertex form that we did in unit 1. So there's our vertical stretch or shrink. This is how we move our graph left or right. So our horizontal shifts and our vertical shifts, we move it up or down. Quadratic graphs have all the same characteristics we've been talking about, but we're going to look at two new ones that they've always had. We just didn't discuss them in the beginning because not all graphs have them. They have an axis of symmetry and a vertex. So axis of symmetry is the x value where the graph is symmetrical about. So it's basically, if I were to draw a vertical line, where does it split my graph in half? If I fold it along that vertical line, where is it symmetrical or a mirror image of each other? And it is going to be our h value from our transformational form. So we're going to say x equals h. We can think about our transformations and what direction it goes. For the vertex, the point at which the graph changes direction, so it changes from an increase to a decrease, it's our maximum or minimum point. And it's going to be our hk from transformational or vertex form. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. So if it's in transformational form, if that is positive, it will open upward. If it's negative, it opens down. In standard form, we look at the one, whatever's in front of x squared. So if it is positive in front of x squared, it opens up. If it's negative in front of x squared, it opens down. In factored form, we usually look on the outside of the parentheses as long as our x's are positive inside. If there's a negative outside, then it would open down. If it's positive, it opens up. This is just a quick example, general example. So if we have a quadratic, there's our axis of symmetry, and we'll do dotted lines to kind of show it. And then there's our vertex, the lowest or highest point. We're going to state the transformation for number 1, and then we're going to figure out the graph characteristics and graph it as well. So when we look at number 1, this 2 on the outside is going to be a vertical stretch by a factor of 2. The plus 3 on the inside is going to go left 3. And then minus 2 on the outside is down 2. We can get some of the information to fill in here from the equation itself, but I always kind of like to look at the graph first. When I look at my graph, I can use my transformations to help me graph. So I know most of the time I go through 0, 0. However, I say I'm going to move left 3 and down 2. Most of the time, if I don't have a vertical stretch or shrink, from the vertex, I go up 1, right 1, up 1, left 1. However, because I have a vertical stretch of 2, I'm going to go over 1 and then up 2 instead on each side because it's symmetrical. And again, most of the time with quadratics, I go over 2 and up 4, but this time I'm going to go over 2 and up 8 from the vertex. One more, right there you go. Whoa, that one got a little wiggly there. This is the nice thing about Desmos, is that it gives you a really pretty looking graph, where if you hand draw it, sometimes it gets a little wiggly. So now I'm going to fill in the rest. My axis of symmetry. So it's the vertical line that will cut this graph exactly in half. So I can add my dotted vertical line there. Our vertical lines are always x equals the value. In this case, because I went left 3, it's going to be -3. My vertex is that point right there. It's always a point, so -3, -2. Our domain is how far left I can go and how far right I can go. So I can go left forever because I have an arrow pointing left. I can go right forever, and I don't pick up my pen or pencil in between. So x, such as x is an element of all the real numbers. For the range, that's my y values. So we're talking about how far down and how far up. I can go up forever because I have arrows pointing up. However, this is my lowest point. Since that is my lowest point, f of x or y is going to be greater than or equal to -2. My x-intercepts here are going to be -2, 0, and -4, 0. My y-intercept, I can't see it on my graph here. I can either look on Desmos or I can plug in 0 for x. When I plug in 0 for x, I'm going to have 0 plus 3, which is 3. 3 squared is 9. 9 times 2 is 18. Minus 2 is going to give me 16. For my intervals of increasing and decreasing, we read the graph left to right. So if I start on the left side and I follow my graph, I'm decreasing. I start somewhere on the left, so my x value is -infinity. And I'm going until -3. Remember, we are taking our x values, and then I'm going to start increasing at -3, and I'm always increasing as I go right. So that's going to be to infinity. An absolute maximum or minimum, they can also be called extrema. That might be a word you see sometimes. I don't have an absolute max here because I have arrows that go up forever. My minimum is going to be my y value, -2, at x equals -3. For my end behaviors, I have a left arrow. So my left arrow, x approaches -infinity. My left arrow is going up, so f of x or y approaches infinity. I have a right arrow because I'm going right, x approaches +infinity. The right arrow also goes up, so f of x approaches +infinity. For problem number 2, you're definitely going to want to graph that in Desmos to give you some points because it is not in vertex or transformational form. Once you graph it in Desmos, you can put it on your graph and we can talk about the transformations. So just because you graph in Desmos doesn't mean you can't figure out those transformations from it. And we are going to learn in this unit how to figure out how to graph that, change it to transformational form, and graph it by hand without having to rely on Desmos. We know that next year there's a good chance we will not have as much access to a calculator in pre-calculus. So when we look at it, this graph has gone right 2, and it goes up 1. I don't have any stretches or straights because I can see here's my vertex, and I went over 1 and up 1. And I also went over 2 and up 4 from the vertex. My axis of symmetry here. So where is it going to? What vertical line will cut it in half? So it's going to be x equals 2. My vertex is at 2, 1. My domain, I can always go left. I can always go right. So it's going to be all real numbers. For the range or y values, I can always go up, but I can't always go down. My lowest value here is 1, so it's going to be greater than or equal to 1. My x-intercepts for this graph will be none. I never cross or touch the x-axis. My y-intercept is going to be at 5. Increasing, decreasing, we read the graph from left to right. So as I am starting the left side, I'm starting with a decrease. I'm starting somewhere to the left, so that's -infinity. I am going into my vertex. The x value there is 2. And then at 2, when I start increasing, my x value is 2. And I'm increasing forever as I go right. So it's going to be going towards positive infinity. Remember, we're talking about how long on the x-axis does something increase or decrease for. Absolute maximum, I will not have one here because I go up forever in both directions. My absolute minimum is going to be my vertex, or 2, 1. So we have our y value at x equals 2 here, so 1 at x equals 2. For our end behaviors, for my left arrow, because I'm going left, x approaches negative infinity. F of x, or y, is going to approach infinity because this arrow goes up. It goes left and up. For this area over here, x approaches positive infinity because I'm going right. F of x is going to also approach positive infinity because I go up. So I'm going right and up. Last two problems are just review to make sure that we don't forget how to plug numbers in and evaluate. So we want to find the value of f of x or y if we know our x value. So I'm just going to take my x value and plug it in. So I'm going to have 4 plus 2 squared minus 7. So that's going to give me 6, which is 36 minus 7, and that's 29. You could just plug this into a calculator. You can also look on a graph and find where x is 4, figure out the y value on the line. So there's lots of different ways to kind of go about this. For number 2, x is negative 5. So I'm going to take that and plug it in. Do a little bit of math. So I got negative 5 minus 3, which is negative 8. Negative 8 squared is positive 64, but because I have a negative on the outside, I'm going to keep that there. And then we're going to get negative 63.